So good afternoon, everyone. Respected session chair, Dr. Prasenjit sir, and all the respected participants. Welcome to IEEE International Conference on Smart Power Control and Renewable Energy, ICSPCRE 2024 conference. So, and this is the track 9. In this track, we have about 9 papers. And for each participant, we are providing a time of 10 minutes for your presentation and then 2 minutes for any queries, maybe from session chair or maybe from other participants. So I request all the participants to conclude your presentation within the 10 minutes itself. Please do not take beyond 10 minutes. And before going to start our presentation, I would like to introduce our session chair, Dr. Prasenjit sir. Dr. Prasenjit received the BTech degree in Computer Science and Engineering from the West Bengal University of Technology, Kolkata, India in 2010, and the MTech degree in Computer Science and Engineering from the National Institute of Technology, Durgapur, India in 2012. He was an associate innovator with Nibio Technologies, Gurgaon, India in 2012. He was a hardware graphics designer at Intel from 2017 to 2018. He received his PhD degree in Computer Science and Engineering from the National Institute of Technology, Durgapur, India in 2018. He was an assistant professor in the Computer Science and Engineering at Cooch Behar Government Engineering College, India. He joined the National Institute of Technology, Rourkela, Odisha, India, as an assistant professor in the Department of Computer Science in 2023, and is currently working. His current research interests include artificial neural networks, pattern recognition, machine learning, etc. He has many research publications in internationally reputed journals like IEEE Transactions on Systems, Man and Cybernetics, IEEE Transactions on Artificial Intelligence, IEEE Internet of Things, Journal Impact, Biomedical Signal Processing and Control, etc. He has more than 15 research publications in internationally reputed edited books and international conference proceedings. He is currently engaged in many government projects. I once again welcome the respected session chair, Dr. Prasenjit sir. Welcome, sir.
Thank you for this warm welcome. Am I audible clearly to everyone?
Yes, sir. It is clear.
Yeah. Thank you for this warm welcome. So I would like to ask the first paper ID 241 to start his or her presentation.
Yes. 241. Please, you can start. You can share your PPT and you can start presentation. Please make it full screen.
Sir, is my screen is visible and am I audible to
you? Yes, everything is fine. You can.
Good afternoon, everyone. My paper ID is 241 and the title of the research article is Unveiling the Innate Potential of Ensemble Techniques in Advanced Brainstroke Classification. So beginning with the content. The content flows like introduction, literature survey, objective, methodology, results and discussions, conclusion and future scope, and last the references. So beginning with the introduction part. The brain stroke is a condition under which the supply of oxygenated blood becomes less to that part of the brain and it starts to malfunctioning. It happens when a brain region cannot get the required oxygen supply because of the blockage in the artery that supplies blood to the brain area. Or it may happen when the brain gets deprived of the oxygen part. In these cases, the cells of the brain started to die and leading to a permanent damage to that brain part and affected the memory recognition by the brain. Thus, this part of the brain is damaged and the surrounding cell lose their vitality and stop functioning properly. The stroke is mainly categorized into the three basic: ischemic stroke, hemorrhagic stroke, and transient ischemic stroke. In these, but in the few decade, the artificial intelligence and machine learning has wider scope in the early detection, and the prognosis and diagnosis of the brain stroke. So, beginning with the machine learning. Machine learning is a discipline of of artificial intelligence that provides machines with the ability to learn from the hidden pattern within the data set, and and form the past experiences, and automatically recognize some hidden patterns to make the predictions with minimal human interventions. The machine learning in this article, the machine learning basic approach is the supervised learning, in which the classification algorithms are applied for the analysis purposes, whether the brain stroke uh, is happening, or is a patient is affected with brain stroke or not. So, beginning with the literature survey that I have done, the author with reference 5 uses the decision tree algorithm. Uh, the author take the data set from the National Institute of Health Stroke Scale, and the training and testing splitting is done on the data set. And for training purposes, 75% of the data, and for testing, 25% of the data is employed, and the model's accuracy is determined to be 91.11%. The next author employed the artificial neural network in the data set collected by the author is from the 507 patients of the Tamil Nadu hospital, and the ANN algorithm is used for the analysis purposes, and this model gave an accuracy of 95%. Similarly, the next author uses the CT scan images of patients, which is collected from basically from Kaggle website, and the dataset, the model gives an accuracy of 95% in training and 92.6% in testing accuracy. The next author uses the dataset from the Kaggle to analyze the stroke prediction via the classification analysis, and random forest gives the highest accuracy amongst the all machine learning models employed for the classification task. The next slide gives us the information about the dataset in description that is used in the article. The patient gender, the data type is of categorical, and this parameter includes the values as male and female only. The age of the patient, which data type is numerical, and which involves the individual's age, and whether the next data text feature is the patient, whether it have the hypertension or not, when where the 0 is equivalent to the no hypertension and 1 is equivalent to the hypertension is present in the label. Next is the heart disease. If a patient is affected with a heart disease or not, and the value in the data type is binary, whether 0 or 1. 0 represents for no heart disease, and 1 for the presence of heart disease. The next feature is the whether the patient is married or not. The here 0 represents the unmarried and 1 represents married. The next is the work type. The data type is categorical, and the values of the data type is the private, self-employed, government job, children, and never worked. The next is the residence type, BMI index, smoking status, and stroke. These are the categorical type in which the class 0 represents the patient is affected with no stroke, and the class 1 represents the patient is affected for may get a chance for a brain stroke. The next is the methodology of the proposed article, and the in which the brain stroke dataset is first and foremost step is the data pre-processing, in which the data pre-processing step, the first step is the data cleaning and integration. The next step involves the outlier detection and skewed data analysis. In the skewed data analysis, the dataset values are checked by plotting a histogram plot, and for checking the median and mean value, whether it is according to the positive or negative. And the correlation analysis, where correlation analysis gives information whether the where two variables are linked to each other. Either the correlation value is 0, when there is no relationship. When the correlation value is positive, it determines that when the value of A increase, similarly the B value will increase and vice versa. Like for example, the A will decrease and similarly for B will decrease. The negative correlation analysis determines the inverse relationship between the two data variables, in which if the A variable's value increases, the value of B variable will decrease, and similarly, when the value of B will increase and the A will decrease. The next involves the SMOT analysis. This basically the dataset available is imbalanced, in which the majority portion of the label are with the
Mr. Preet Singh, you have
yes.
only 3 minutes more. Please try to conclude within 3 minutes.
Yes, sir. For the SMOT
Yeah.
analysis is the synthetic minority oversampling technique, and the further training and testing data split is 80-20%, in which the XGBoost, CatBoost, and LGBoost classifiers are used.
Dear
And the way,
participant, your slide is not moving. You are maybe in some different slide. Can you look into it?
sir, it's now moving or not?
It's moving. You are in right now. It is results and discussion slide. We are
Yes, sir. Yes, sir.
yeah.
So this is the basically the confusion matrix generated by the all the three classifiers that I have implemented in this article. And the next is the voting ensemble technique, in which the truly predicted value of the model is 951, and the for class 0, and true positive predictions made by the model are 882 for class 1, and the false predictions made by the models are 61 in this voting ensemble model. And by comparing the accuracy, the weighted voting average ensemble technique outperforms the other machine learning classification algorithms with 96.7%. And this is the precision and recall comparison for class 0, in which the weighted voting ensemble recall value and precision value is higher as compared to the other algorithms. And similarly for class 1 also. The next is the conclusion and the future scope. The ensemble technique used involved in this categorical analysis combines the weights of the all ML algorithms, and you should then utilize them to improve the functioning and
Finish
performance.
it quickly. Finish it quickly. You have already passed the 10 minutes. Try to
Yes.
wrap it up.
So that is the last part, the conclusion, in which the weighted voting ensemble technique outperforms the other with the 96.7%, and the future scope maybe involves the uses of the brain CT scan images for involving the deep neural network for classifying the chances for the brain stroke classification. Thank you.
Okay, so I would have some questions for you. Like, what is the reason behind choosing these models for the ensemble? So, as you have, I can see like CAT boost, LG boost, XG boost, and weighted voting average after that. On these three model you have taken. So, what is the precise reason for choosing this model? Like, ADA boost is also there. Why you have not selected that particular ensemble learning technique? Can you justify?
Sir, because for the learning purpose, I have implemented these three models, and these three models are initially also based on the ensembling technique, in which the decision tree is the weak model, and further it will learn from the residual errors, which is created by these three boosting techniques, and the final model will outperforms the other decision tree weak models, and which combines basically the accuracy and learn, and the each subsequent model will learn with the errors of the previous model.
Okay. So, and what the data set which you have used, has it been used by other researcher? Like, can you show me a comparative table? Is it present in your presentation? The comparative table where you have the same data set has been also applied on some recent work. Is it there?
No, sir, I have put it in the article, but it's not, I have added it in the presentation. I will add it in the
Okay.
future scope.
You should have added. Because the data need to be validated, whether it is the data which are used by other researcher or not. So
Okay.
I would also like to say that how you have decided that which ensemble model will have a higher weightage and which ensemble model will have a lower weightage. Like you are weighting among those three models now. I need to know how you are giving the weightage.
So the weight is calculated by combining taking the mean of these three models, in which for example, I have taken accuracy as a metric to calculate the weight, in which 0.956 is the XGBoost accuracy divided by the addition of all the accuracies, which gives me the weight of the XGBoost. And similarly for other models.
Okay, thank you. Thank you for your presentation.
Thank you, sir.
Thank you. Please stop your. So now I request the paper ID 242 start your presentation. Chaitanya Prakash Kale or Mahendra Gawali. And also I request all the participants while you are giving your presentation, please try to switch on your camera. Please switch on your camera and please stick to 10 minutes. Try to complete within 10 minutes. Please switch on your camera.
Yes, sir. Am I audible, sir?
Yes, you are audible.
So, good afternoon, all. Myself, Chaitanya
please,
Prakash Kale.
Please switch on your camera.
I already on, sir. But problem with that is.
Okay, maybe.
Can you just turn off and turn on your camera again, because it is also not visible to me.
Not visible.
Is it visible, sir, now?
You can start. No, it is not visible, but yeah, you can resume.
Okay. So, good afternoon, all. Myself, Chaitanya Prakash
Can you make it full screen? Can you make it a full screen?
Yes, sir. Yes, sir. Okay. So, my paper ID is.
No, it's not yet in full screen. Please make it full screen.
Yeah, I already did the full screen, sir. Maybe it will take time. Get back. Hello.
No, you can again come back from full screen and start again. Again, you go to full screen. Just repeat that. Maybe then it will come.
Is it okay, sir, now?
No, it is not okay.
Not.
I think there is some problem with your site. It is not full screen. Your face is not visible.
Not visible.
Can you quickly, time is also running out. Can you quickly leave, rejoin, and check everything is
okay,
you
sir.
are not do it fast, huh? Within 30 seconds. You do it.
Yes.
So meanwhile, I request other participants also, please check your internet connection now.
Hello, sir.
Yes, please. Please.
Yes, sir. Is it okay now, sir?
It is still not. It is not full screen. Your face is still not visible. But continue, because you need to wrap it up within 8 minutes. Huh? Okay.
Okay, sir. Okay.
Start.
Yeah, sir. Good evening, sir. Myself, Chaitanya Prakash Kale. My paper ID is 242, and my topic is Advancing Offshore Wind Turbine Energy Generation Prediction through Comparative Analysis and Novel Machine Learning Techniques. So, In my research, sir, basically, this is my PhD research topic. The content of my presentation is introduction, literature survey, objective, methodology, result, conclusion, and references. So, sir, nowadays the
Are you
wind
sharing
turbine.
the current screen? Are you sharing the current screen? Because I am only seeing the first page.
No, sir, I
Yes,
shared
sir.
the
Even right.
Can anybody confirm whether he has moved
Yes,
to
sir.
second page?
Yes, sir. Now he is in third slide, sir. The introduction slide is visible.
Yeah, it has moved. Okay, start.
Okay. So nowadays the use of wind turbine is growing. The wind turbines means there are two categories: offshore wind turbine, onshore wind turbine. So my research study topic is related to the offshore wind turbines. So all the parameters I consider in the study, that is sea, then rivers, etc. Where are the possible to install the wind turbines? So when we consider any offshore wind turbine, there are some challenges, many challenges from starting to the installation of wind turbines. So currently, the absence of energy generation framework. Okay, I study many papers. I did the literature survey. I found there is a lack of research in the energy generation prediction in the large amount of manner. Number of models are available, but they are only predicting on basis of some parameters. So in this research, I'm trying to explore the new technologies related to the large energy generation prediction. So here are some latest one technology, Industry 4.0, digital twins, then digital visualization. Then by using the power cut model, also we can predict the energy generation. So in my study, I am using the digital twin technology to predict the energy generation in the large amount by considering the latest one data sets. So when we are doing the research by considering the Industry 4.0 model. So basically, to prove this model, I'm using some machine learning concepts, machine learning models. So in my upcoming slides, the machine learning models are available. But when we consider any machine learning model, okay, before that, we required one specific data set. So basically, I'm considering three government data set websites, and one is the nearest wind farm is available in the Sinnar MIDC. So that's also I'm considering. So I collected the live data set from the Sinnar MIDC. There are some wind turbines already installed, and I collected data set for my research. So in the literature survey, I did the literature survey of
Sorry to interrupt you. Are you in
yes.
which slide? Still, we are able to see only third slide.
Okay, sir.
Yeah, now it is moving.
Okay.
Now
So
it's
in the So in the literature survey, I did the literature survey of near about 40 to 42 papers. In this presentation, I put only 6 papers. So in that, I found the similarity. Many of the researchers can consider the parameters like wind speed, then the turbine speed, then blade size, but no any exact proven result is available. How the energy is generated in large amount of manner. Some traditional methodologies are available to predict the energy generation. But nowadays, digital twin is the trending technology. Okay, with the help of that digital twin trending technology, we can predict the result by using the machine learning concept. So this is one sample paper. In this sample paper, machine learning techniques are used. Then KNN algorithm and TCN algorithm is used. Then second one, in this paper, um, it is the objective of this paper is to develop a predictive model wind turbine for the gearbox. Means in this paper, the gearbox is the parameter and module uh, to predict the energy. Then third one research paper. In this paper, the CNN predictive deep learning is used to predict the energy generation. And in this paper, the gap is identified. Whether the CNN technique is more applicable or any other technique is more applicable, that is proved in this paper. Then next one paper, in this paper, uh, the SVM support vector machine, then KNN algorithm, RF, deep neural network, these technologies are used. So by considering this paper, I have finalized the objective of my research Okay, so first of all, to do the deep study of previous one methodologies, then to do the comparative analysis. So basically in this paper, I am working on the comparative analysis, and for the comparison purpose, I have taken total five to six algorithms. First one is the SVM, second one linear regression algorithm, third one is the voting classifier algorithm, fourth one random forest algorithm, fifth one XGBoost, and sixth one is the latest one, explainable artificial intelligence. So basically, I have implemented uh, first five algorithms with the help of Python programming. The code is available with me. I applied the data set. I check the result. So same screenshot I have put it here and paper also. So this is the SVM result. The first one figure, it shows the SVM result. Second one, linear regression. So in this one, I have considered the three parameters: wind speed, tower height, and blade length. So on the basis of these three parameters, I have uploaded the data set and checked the algorithm result. So first three algorithms, support vector machine, linear regression, XG boost algorithm, this one slide also, voting classifier algorithm also, are relatively same result. Means when we check the data set with all four algorithms, it will showing the similarity in the result. But when I move towards the random forest algorithm, so the random forest algorithm shows the efficient result, continuous progress, upward result as compared to the other machine learning algorithms. So in my further result, I am using the random forest algorithm. On the basis of random forest technology, I am trying to developing the